industrial process instrumentation. It is basically when you enter into any factory, you will find lots of pipelines and vessels on which many of the instruments are mounted. Why I am telling you? Because I have worked in such a process industry in a power plant. I am a DP Bhoyer, worked in Mahagenco and Reliance Power nearly for 36 years in electrical and instrumentation engineering. So, industrial process instrumentation, I have seen the tremendous change since 1970s up to 2020. Lot of technological advancement has been there in your measurement technology, automation and control. You will find the process particularly which is an operation or a sequence of operations involving a change in the substance which is being treated. Steam generation, the water treatment, the refrigeration, the air to flue gas conversion, combustion, grinding of coals or rolling mills. Those parameters are controlled through the pressure level, differential pressure or flow transmitters. Those transmitters, you will find pressure transmitters are nothing but the electronic modules. Earlier they were pressure gauges, local measurements were available. Nowadays these pressure and temperature transmitters are basically the electronic modules which converts physical quantity into electrical signal and transported to control room. Temperature transmitters are basically RTD and thermocouples which converts those quantities into electrical standard signals of 4 to 20 milliamps or nowadays digital signals. Level measurements has seen a tremendous change. Earlier it was just a gauge glass or deeper stick measurements. Nowadays it is you will find many DP transmitters up to ultrasonic and radar type of transmitters. So these all transmitters basically are fed to the controllers in a control room which has a electronic system. Earlier solid state electricity, nowadays it is nothing but a microprocessor based controllers. The controller is nothing but the mapping of any process which has the input and outputs, and ultimately feedback is taken from the measurement given to controller compared with the set point with the process variable and given to final control elements. Transducer is nothing but the conversion of physical quantity into the electrical signal, and that signals are nothing but the capacitance, resistance, millivolts or thermistor, and those electrical signals are then converted into the transporting signal of 4 to 20 milliamps or 3 to 15 psi. Those are transmitters basically. Those transmitters, and then these are connected to controllers. Controllers are nothing but to keep the process variable at the desired value. Those are open loop or closed loop controllers. Those are various type of modules: on-off module, proportional action, proportional controller action, that is PI controller or PID controllers. Signals are fed to the indicators or recorders, and then it has been evaluated in our control system and shown on the DCS and made available to our operators. Control element is nothing but the drives which are control valves, lowers, dampers and the variable frequency drives. Just see the mapping of one control loop which I have shown here. The pipeline which has a process fluid, primary element which has a orifice, then transducers, transmitter which is shown an indicator, controller, recorder and controller again given to the E2P converter, and then final element of actuator which drives the stem, and accordingly process variable is controlled. Control trust is nothing but the measure, compare and adjust. The controller types are various types: the pneumatic, analog, digital, that is single loop, distributed controller or field bus controllers. Control loop is nothing but pressure transmitter or temperature transmitter signals are taken, fed to the controller, and then final element is controlled through the control valve. The temperature controller, the flow controllers, the level controllers are similar in nature if it is taken in the control room, because those are converted from pressure or temperature or level or flow transmitters, and those 4 to 20 signals are then evaluated and exploited in a control room, and compared with the PV, that is process variable and set point, and given final command to achieve 4 to 20 milliamps or a digital signal to or a final control element, that is a drive. Those single loop controllers, when it is made multi-stage controller, become the cascade controllers. So in a very big process industry, you will find many as a cascade controllers. Control algorithms are the on-off controller, multi-step controller, and those PID controllers. How these are selected is through the control algorithms. Control algorithm is nothing but the flow charts based on which you can find out the response of the process, and accordingly the P or integral, that is proportional integral or PID controllers are selected. PID action is again it is a time demand or time step demand, you will find, which is how the process can be stabilized as per the PID controllers. Today's DCS network, you will find a lot of IO racks controllers. All the signals are taken to the control room through, earlier it was through the many wirings, but nowadays it is through the intra-plant bus or the Profibus or a special open network buses. You will find in a control room lot of IO racks, controllers, and diagnostic kits for which evaluation of performance, and the tools for the process analysis and diagnostics. These DCS nowadays or PLC has a various controller distributed throughout the plant, and because of this, a lot of wiring has reduced, and ease of operation has been there for the operators. Nowadays you will find the what we talk about Internet of Things or the artificial intelligence, which has made the things very easy for the control of any process or process variable, and any complicated or any big process is available on your laptop or mobile through this Internet of Things and cloud storage. So dear friends, in this little bit talks, it is very easy, and you will find out that these things with the advancement in technology